Good morning, folks. Took an early start, and we're right on time for day 3 of Advent of Code in F Sharp, of course. So let's get right to it. Day 3, binary diagnostic. Okay, so we've already seen list reductions, Mars rover kata, and binary enters the fray. Cool. The submarine has been making some odd creaking noises, so we ask it to produce a diagnostic report just in case. The report, which is our puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. Okay. We need to use the numbers in the report to generate two new numbers called the gamma rate and the epsilon rate. As long as it's not Omicron, we're good, right? The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Okay, so two numbers again, need to find the product. Each bit in the rate can be determined by finding the most common bit in the corresponding position. Most common bit in the corresponding position. So for every position, we need to count the number of ones and the number of zeros. Most common one is the way we calculate gamma. Okay. First bit of each number, there are 5 circles. Yep, makes sense. Okay. So we have an example for the gamma rate. Epsilon rate is similar. The least common bit from each position is used. That's the inverse, right? Like the binary negation. Yes, that's a good sanity check, or we can only calculate one and negate the other. Or negate the number to get the other. Is there a way to infer the decimal if you know one of them? It's a 1, 2, 3, 4, 5 bit number? Maybe. It's too early to think about maths. Okay, so we need to figure out two numbers. Cool. And then we just have to multiply them. Okay, let's grab the input. But these are bigger numbers. And there are quite a lot of numbers. No, yes. 1,013-bit numbers. Whoa. First things first, let's grab those numbers. Yes, and let's grab the example. Why is it not liking? Have I not been doing it exactly like this? Okay, it needs some indenting. And let's do the trimming anyway, because last time I said no. Now we'll say yes. Come on. Give me something that is a bit pleasant to the eye. Does it trim, not trim? Interesting. I thought a trim would trim. Oh yeah, it only... Okay. It's an array and we need to trim every element in the array. What does a trim do on an array, actually? Why does a trim exist? Okay, it doesn't. So we were only trimming the input string. Okay. The curse of streaming at 6 o'clock in the morning. The brain has not woken up yet. Okay, so let's do a quick split is what? An array. Let's do a quick array. Let's do a quick trim. Is there a native trim function? No, there is not. I mean native, but I say native, but I mean F sharp specific without the string dot thing. Okay. So we need to count for every, what do we call that? For every place, for every location. just the first bit. So we have to go over every... How do we do this? We can still loop over all the numbers, and we just maybe index every position, so that we know at index 0 we have a 0 for the first number, and for the second number we have a 1, and then just do a index-wise summation. That would work, right? Yeah, let's start playing around with it. Do we need to parse? We don't actually need to parse anything. We can work on characters, right? I think so. Yeah, let's first transform these numbers. Or let's first apply an index. That should give us... maybe it's not a list, but a sequence. A string is like... Oh yeah, that's an array, and list.map doesn't work. This should give us, for every number, an indexed, or every bit is now indexed. And if we now sum the numbers based on index, that would work. Am I making it harder than should? Probably, but I don't care. How do we write a sum function for this? We can do a reduce. Reduce is literally a fold without the initial state, so it takes the first element as the initial state. Or you cannot use a reduce on a empty array. A fold you can use on an empty array, so that's the difference. And then we need something to aggregate. I'm at a loss for words. My vocabulary brain is not working. And that should give us, yeah, something in the same lines of what we're doing. So that should all compile and work. Yes. Maybe let's do a toList so we can actually see stuff. Sequences are like the IEnumerable, the lazy evaluated thing. Lists are where evaluation happens. Okay, so this will work probably. Let's count the number of ones. Yeah, sure. How do we do that? How do we do that? So we need to... I don't know why I explicitly indexed everything. We can just do a for loop over one of the numbers and then grab the index in the first number. But I went down this road, so let's keep going. I'm starting to doubt my indexed approach, so let's get rid of it. Let's get rid of it. Yeah. So I think if we just do a zip of both numbers, so n1 sequence.zip n2, and we get like pairs. So for every digit we get a pair. Do we need to do that? No. Ah, yeah. Okay, so we're living in the character world, and I'm trying to add numbers, so we need to go into the numeric world. So I think a fold might actually be better. Yeah, let's do a fold instead. It's almost the same, except that for a fold we get a state, which is our count, and the t is the element in the array, so we need a state, let's call it count, and a number, or yeah, a number, it's not a digit, and we just return the counts. And then we don't need to do a toList because it fold already. Actually, we didn't need to do a toList before. Okay. Why is it complaining about type inference? Okay, let's... Oh, okay, never mind. Let's do something instead of trying to make the compiler happy first. So counts will just be an array, and at every index the number of ones or zeros, I don't know yet, but so how do we do this? I am completely blanking, so I'm just gonna do for loop or a for comprehension. Is this how you do a for loop in F#? I don't know. Do we need to index that? Yeah. So if we grab the index and the number or the digit, let's call that digit and index, then we just do I'm dropping my brain is not working in a functional way this morning. It's like dropping into I've seen a lot of Python code by other live streamers, and my brain is in Python mode right now. But how would we do this? And then we would say, okay, do a plus plus with n if it's a 1 or if it's a 0. Yeah, actually this would work then. So I'm just writing a pseudo algorithm right now. I think this would work, yeah. Now, how do we transform this into a functional thing? I think we can do the zip thing we were originally doing. So zip the counts with the current number, and then do a map. So then we have a count and a digit, and if the digit is a 0, then we can return the count, and otherwise we need to increase the count. Schnonk, I think that might work. Why is it not happy? We need to provide it what does a zip do with lists of different lengths? I think it takes the shortest length. Yes, it takes the shortest length. So actually, this will only work if we give it a list of at least a number of digits. Don't know if I like this approach. Just gonna hard code something. What do we have in the example? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Folder S, state second. What is not okay with this? So we have a sequence of characters. Oh, am I mixing up? No, I'm not mixing up. Fold takes the function. Function itself takes a state and a number. So state and a number. Why is this a... it's because of the zip is throwing me off. It's this is the other way around. There we go. Yeah, let's do a list to look at the bit string or the number of counts. Is that correct? 75875. There are 5 0 bits and 7 1 bits, so oh god, yeah, I'm counting, but we need to know whether there are more ones than zeros. Okay, now we're counting the number of ones. We can still go down this route. But then we need to know the amount of numbers. Let's make count a bit smarter. Instead of a number, let's make it just a running tally of zeros and ones we encountered. That will be easier. I'm just gonna write a quick type. So, because if it's a number, I can live with type inference working. But if it's like a complex type, I like some documentation. So number of ones and number of zeros. And if we take tally as our... Oh yeah, it should be a list of tallies. Yeah, so it should be a list of tallies. So we zip the list of tallies with a number. Yeah. And this is the tally. So we update the tally. And otherwise we do the tally plus. Or we increment the number of ones. And the initial state is not the magical list, but the 0 count. Cool. That would probably also work. No? Why you know work? Oh yeah. Okay. Ooh, it's worse. It's actually worse. Or let's just create a list containing as many of these as we need. Repeat, is that? Replicate. Yeah. So let's replicate the number we need. So our initial state is just a list containing 0 tallies. We zip that with every number using a fold. And we just tally up. It's pretty complex, even for my brain, so I don't know if I like this approach, but it appears to be working. So 1 should win, 0 should win, 1 should win, 1 should win, 0 should win. 1, 0, 1, 1, 0. I think that looks correct. Final 3 rates. Okay. And then we need to... Okay, so we need the binary number with the winners. And for the second case, we need the binary number of the losers. And then we need to multiply. Yeah. Oh, how do you go from binary to decimal? Chat, help me out here. It's been a week. Let's first get the numbers in binary and then we'll do the actual conversion. Or we can do a bitwise multiplication and convert afterwards. I'm just gonna save this off so we can play around with it in a variable called tallies. Okay, so yep. Okay, let's do a map over this thing. No, it's a list, so I'm gonna keep it in the list world. So if the tally number ones is bigger, it's a 1, and otherwise it's a 0. So that should give us the binary-ish representation. Where is the full number here? 10110. Yep. So this is called gamma. Yeah, and the other one is called epsilon. And that's literally the... Wait, so if we have... What was the gamma thing? The epsilon thing again? The least common bit. So we have to take the lower number. So if number ones is bigger, then it's a 0. We can just do this. So that should give the binary complement. It gives us the binary complement, so that's a good sanity check. And now we need to multiply these and have the result in decimal. It sounds like multiplying two decimal digits, binary digits, is something easy, but my mind is completely blanking. Let's do a quick Google search. I'm trying to get rid of my bookmark bar, but Chrome is bugging out. Okay. Binary multiplication. Is this something we want to do? No. Let's just convert to decimal. Is there a quick way to convert binary to decimal? We are working with computers, so I hope so. Yeah, that's how to do it manually. Is there no better way? I know there's like a, what is it called? Convert with a base. O'Reilly.com. The C cookbook. Maybe that's not what we need. Oh, come on. There has to be an MSDN link somewhere here. Mm-hmm. That sounds more like it. Convert to int32. Let's take a look at what we have there. System. Where are you? Convert. Yeah, there we go. It takes a value. Where's my base? There's 14 overloads. That's a lot. Oh, come on. Where are the... So it takes a value in a string? No. Does it have to be a string? Why can I not see all overloads in one fell swoop? Does it have to be a string? We can do a string, but yeah, let's try it out with the example. So 10110. I feel silly for going through the integer loop and now having to drop back to a string. But yeah, that works. 22 is what we were expecting. Right? Yes, we were. 22 plus 198 is 220 for a 5-bit number. I'm trying to figure out whether we can figure one number out if we know the other one. I think so. But okay, let's just do this to string our binary numbers and use this convert method to drop back into base 10, and then we have the numbers. How do you convert a list of numbers into the string? Oh, there is a string concat, which takes a separator and a sequence of strings. So let's first map it to a sequence of strings. This converts every number to its string representation, right? Yes. And then we can just concatenate by using the empty string as a separator. That should give us the binary. Yep. I'm just going to copy paste the entire thing over. This should give us the other one. Yep. I'm just going to write a quick function for the conversion. So we have a convert to decimal function, and we can provide strings to that thing. So let's do that. This should give us 22 and 198. That is not the case. What? 9? Oh yeah, it gives us 9 and the product is... Okay. So the product should be gamma times epsilon, which is 198. And okay, let's put this in a function. What is the actual thing we're doing? It's these and this. I'm gonna put my converted decimal a bit higher, seeing that it's unrelated to the styling. That's just a type. That's just a fold helper. Yeah, I'm just gonna write a function solve, and let's drop everything in there, and let's have it return the gamma, the epsilon, and the product, so we can inspect every step in the process. When things go wrong, let's try it out with the example. Oh no, we maybe need to use the input argument. Where do we use it? Right there. Yeah. So this should work on the example. I'm just gonna make sure that it fails. What? Oh yeah, it's a triplet. 0, 0, 0. Let's just see what comes out. It should be 198. 22 and 9. 22, 9, 198. That looks correct. Save that for later. It works. Let's do it for our input. We have a number. Hey, part 1 down. That deserves a sip of coffee. I'm gonna quickly prepare for part 2 by copy pasting and don't giving anything about part 1 anymore. So, what's being asked of us in part 2? Oh, a lot apparently. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Whew. Both the oxygen and the CO2 are values that can be found in our diagnostic report. So we have to look into the numbers and we need to find the relevant ones, but it's tricky. Oh, great. Both values are located using a similar process that involves filtering out values until only one remains. Are we okay? Before searching for either rating value, start with a full list of binary numbers. Cool. Consider just the first bit. Then keep only numbers selected by the bit criteria. What is the bit criteria? Is this something we've seen already? No. There we go, the bit criteria. Okay. So need to go over the entire collection, consider just the first bit, and then filter that list by using something called the bit criterion or the bit criteria multiple. Everything that doesn't fit goes out, and if we have one number, if we reach a fixed point, we stop. Cool. Otherwise, reduce the list until we are closer to the fixed point. Cool. Bit criteria depends on which type of rating value you want to find. So we have different criteria for the different ratings. Cool. Oxygen and CO2. This is literally what we have been doing. So we need to do the thing we've done once a lot of times. Brain wake up, please. Okay, we're going over the list. We need to find, for the first bit, the most common value, and then filter that list. So we only keep the numbers that have that most common value as the first bit. And the other one is least, so it's the complement thing again, yeah. An example will be handy right about now. Oxygen is the first one with the most common, cool. We have the full list. We take a look at position 0 or index 0. We can look at which bit is most frequent. And then we take those numbers with that most frequent bit. Cool. Then we go to the second bit. Okay, that's the same thing. Until we reach a list of size 1. That's the end state. Cool. And this is with the least. Okay, I think I understand a process now to code it. So we should have 23, 10 to 30 for the example. Okay, what changes? What changes? We did the tallying just the once. Now we need to do it repeatedly and filter the list in between steps. Right? Right. I'm already not going to put everything in this huge solve function because we need to do a bit more this time. Yeah, let's get rid of that test. So we need to start reducing this list down to size. Let's focus on one of the two first. Let's take the oxygen first and see how we figure that out. So let's drop back into the example world. Okay, I think we can use our fold magic and our aggregate magic, but we need to do more. So example. And we need to do something for every... Do we need to do something for every index or every bit position? Yes, or at least until we have a list of length 1. So I think we kind of need to know about the index we're processing. Yeah, this is already a bit tricky. I'm just gonna write literal functions, not think about which collection functions we can use. And we'll get there eventually. So we need to filter out, and to filter out we need to know the most significant bit in the position we're looking at. So let's just... Should I... Should we use the index? Yes, we need the index. Because we start and take a look at the first bit, and then the next step we take a look at the second bit. So actually we don't need... Yeah, but we know that it starts at 0 and it increases. So, okay, step back. First bit. Let's just write the implementation for the first bit and see where that takes us. So the first bit is... We take the entire example set, we do the tally for the first bit. Actually, this makes no sense. This is doing it for the entire bit string every time, but we only need to do it for one column or like one index position. So actually we need to do a... yeah, let's try this. So for every bit we have, do grab the nth bit. I think there is even an nth. Is there not an nth? There used to be an nth, or is it list.nth? Item? There is a function that... Yeah, so this takes an index. So now we have all the first bits. Does that look correct? It probably is. And then we just count the... What does count by do again? Well, that's actually what we need. So count by ID. Does that work? Yeah, so we count the number of zeros, the number of ones. Actually, this looks way easier than what we did for part 1. Okay, never mind. Yep, and then we take the maximum of those two. For the oxygen at least, so it's sequence.max by... I still don't understand if I type MB, it gives me sum by as the first hit. Why wouldn't you not provide me with the word starting with an M? Anyway, and we need to max by the count, which is the second element of the pair. And then we just take the first element of the pair to drop back into the bit world. and that should give us the most common bit in that position. So let's call it most common bit. And then we can filter out every bit with and then we can filter out every bit that has that most common bit, right? For the oxygen, it's the most common. And we should have 7 numbers, all starting with a 1. So I'm gonna extract this 0 because we will need it again here. And then we filter out the example. Is example, what was it again? Sequence and arrays, okay. Of digit and digit at index should be our most common bit. And those are the numbers we want to keep. Index is not defined, cool. Send it to the REPL. Most common bit is not defined, I'm sorry. I'm just gonna select everything. And let's toList it again. We won't be winning any speed records today. Oh geez. So 1, 2, 3, 4, 5, 6, 7. That looks correct to me. And now we need to do this recursively. Yes. And we always increase the index up until the moment where we have just the one binary number. Yeah, I'm just gonna write a recursive function because I'm still not sure if we can do this with one of the existing collection functions. So how would this function signature look like? Filter, given an index and a set of digits, sure, and we return a smaller set of digits. Right. So instead of example, let's use digits. And the index is something we have. So in theory, without doing anything about the recursive thing, filter 0 example should give the same result as we had. Digit index. What is digit again? Digit is an element of digits, which is why is it not happy? Let's call it what it is. It's a sequence of strings, right? It's a sequence of strings. Okay, so this should be exactly the same as what we did, but in a function. Yeah. And sorry, and let's make it recursive now. There is this dot syntax for indexing it always looked weird to me, and F#6 now supports the indexing without the dot, but I think my auto formatter doesn't like it yet. So when my auto formatter kicks in, it breaks the syntax. But it's possible in F#6. You can do indexing without this really weird dot in the middle. Let's make this recursive. What's the stop condition when we reach a list of one element? So I'm just gonna make this function recursive. If all else fails, drop to recursion. And first thing I do, make sure this function ever stops. So digits. If we have just the one. Yep. Then we're done. Yeah, let's just return the list. Let's just not grab the element in the list just yet. And otherwise, we do the thing and we do the recursion. So let's call this the filtered list, and let's recursively call ourselves with the index +1 on the newly filtered list. That should work. It gives us 10110. Nope. Oh, wait, am I looking at the correct thing? Yeah. In the fifth, blah, 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 key the number with a 1. 10111. We have a bug. Yeah, we have a bug. Okay. That's a shame. Let's do some print driven debugging. Let's get rid of everything. So I'm just gonna print out the steps in between we have. So let's print out digits. Where is the bug in our thinking? This is the full list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. And in the first step, we should filter down to 1, 2, 3, 4, 5, 6, 7. That actually still looks correct, right? So, first filter step, that looks correct to me. Second filter step should take a look at the second digit. Are we using index wrong? I don't think so. Don't think so. It's okay, so consider the second bit. Second bit is a 10000101. I think I heard more zeros than ones. Yep. Keep only the 4 numbers with a 0 in the second position. So we have 1, 2, 3, 4. This also looks correct. Oh boy, what's the problem here? 10110 10. Yeah, looks correct. Third position. We should have 3. Yes, yes, yes. That's also correct. Where is the bug? Why is the last why is the last filter step failing? Oh, there's an equal number of bits. That's the edge case. Why, if you have an equal number, do we drop to 1 as a default? Was that something they gave us? Okay, if they're equally common, keep values with a 1. So 1 wins. Okay, that's something we have not done. So instead of just using a max by, we should let ones win. Okay, so digits map count by. What does count by give? The key and the int. Okay, and then just let's just do something stupid. Then order by, sort by. What's it called? Let's just sort by the digit. That should be better, right? 1 0. No. Ah. I'm confused now. This whole pipeline thing. Let's print out what we have here. So it's just like a stupid print and return. I learned it yesterday from someone else's stream, doing it in Kotlin. So yeah, we have a 0. Oh yeah, it's characters, not numbers. And probably the character 0 comes first. So let's do a... Ooh, this is not some code I want to maintain. Is it a sort descending then? Let's try it. That's better, right? That's better. Let's convert that to a decimal to make sure. What? It needs a string, and we have a sequence of strings. Oh yeah, we need to grab the element out of the list, because I thought that would be a good idea. Already regretting my decisions. Yeah, okay, that works. Let's get rid of the print statements, the debug pipeline thing. And actually, let's get rid of all the part 1 code that was super useless. If you look at what we're doing right now. Yes, this can also go irrelevant. What changes for the second number we need to calculate? Max by turns into min by? Probably. Yeah, max by turns into min by. We need to keep the least common value. Okay, I'm just gonna do something here. Filter, what's the first one? Oxygen generator rating. And that's what we've been doing, but with a sequence dot max by. So I'm just gonna provide the thing that changes as an argument. How will we call this function? Decider. It's a bad name. I don't like it. Why is it not working? It should know about the filter. Okay, yeah. We need to provide in the recursive call. We need to provide this function so everything works. And then if we use this function instead of the original one, we get oxygen. And then we can just pipe in something else for the, what's it called? The CO2. And that should use a min by. Why is there a red squiggly line? Wow, it's complaining because we don't use it yet. Okay. Let's see whether we get the correct value for that. What's the correct value? It should be 10 in decimal. Ah, another bug. Of course. Of course we have another bug. Yeah, let's do the same thing. I should have kept my debug stuff. It's day 3 and I'm already like struggling. I think the week is starting to get to me. It's been a heavy week for work as well. Oh yeah, I would like some print statements, please. Let's clean up the REPL and let's do that again, just for this case. So 12 numbers. And we should have this list. Ah, it's going to be a edge case again. I sense it in my little toe. Yep. Then 2 numbers. Yep. And then again. So probably now. No, I'm confused. Why is this? Okay. Great. That's too bad. I didn't notice that the edge case thing with if they're equally common, we keep a different digit. So here we keep the 1, there we keep the 0. So also the the sorting is a bit... Ah, that's a shame. We already went down the dark path. I'm just trying something. Can I pipeline? Yeah. Don't shoot me. This is not something you should be doing. To write maintainable code. But I'm just gonna grab the thing that differs and provide that as an argument instead. We'll clean it up later. I just want to get it over with first. So probably this will give us something more relevant. It gives us a 10, which is what we expect. Yeah. Let's leave the debugging in there. So what did I just do? Everything that changed between the two, I provide as a function. Is this maintainable? Hell no. Is it confusing even me? Hell yes. Does it work? Sadly, it does. Wait, what? Why does this one not work anymore? I think we need to do something with the returned values so the compiler or the type inference knows what we're doing. CO2. And we need the product again. So oxygen multiplied by CO2 should give us the 230. And now the type inference should be able to figure it out. Right? Right. Cool. Make it work, make it right, make it fast. So let's first... let's first just do this for solution. Make sure we are in the correct world. Or we are working with code that does what we expect. And then let's clean it up if we want to. Yeah, I'm just going to write a function as I did before and do the calculations in that function and have this work on the input instead. I'm also going to use, oh, sorry, where's my page down button? I have like a let lights go brr keyboard, but it's really small and I need to press several buttons to do basic stuff like page down. That's a bit of a shame. So yeah, I'm just reworking this. So it uses the input argument and refactoring to a pipeline style. So the steps are very clear. And of course that's not working. Why? Because for some reason we need to keep specifying that this is a sequence of strings. And let's solve the example, which should still give us 230. Sorry. Yes, it should give us 230. So let's grab that, put that in a test. Since I want to refactor now, so I would like to keep this around. Yeah, okay. I'm just gonna make sure that everything works by running everything. Whenever there's a NuGet load in there, the rerunning of all the code in this file takes a bit longer. But that works, so let's solve it for our input. We get a somewhat big number. Let's see if we're still correct. Yay! This was harder than it had to be. I'm just gonna take a quick look at the leaderboard. We do a bit of competition at work. I suspect I will not be the first one. Oh, Hugops, it's a bit slow, the website. Okay, there we go. Yeah, we already have some people. I logged out for no reason. Okay, Let's take a look at the code. What don't I like a lot, actually? This is really black magic. Okay, it's only 1, 2, 3, 4, but we had a bug in there or an edge case, and troubleshooting that was really hard. And now we have even more black magic with this decider thing. So I'm not a fan of that. Otherwise, it's okay. I can live with it. But this part, no. This is it already does not make sense anymore to me. It's like a sword and then followed by a max buy or a min buy. How would I clean this up? On a fresh mindset, at least. I don't like it when it makes these things asymmetrical. I'm thinking, what's the best way to clean this up? We could move the logic back in here and have like a if we're yeah, we need to know which case we're handling. Like, is it the oxygen thing or the CO2 thing? Because in both cases, we need to give favor to another digit, right? Yeah. Okay, I can't see the exercise again because I logged out. You know what? Let's call it a day. I've been working for an hour. We might refactor this later into something I would not mind supporting. But yeah, we solved it. I think we over-engineered part 1 by a lot. Part 2 is not really over-engineered. It's made very complex because of this pipeline thing. So if you have some ideas on how to refactor this or how to make this more understandable, please let me know. All right, thanks, and I'll see you tomorrow for another episode. Bye-bye.